right, all right, all right. We've got a little bit of an audience here for you specifically, Matt. You know, it says Russ Sorrells, but don't mistake. This is the one and only Matt Matheny here to talk us through some of the changes that have gone on in the HVAC industry, specifically around governmental regulations for the refrigerant requirements that is going to cause some transition in the industry as far as charging systems, some of the flammability challenges that go around that. Matt will speak to that. He is a subject matter expert in this particular conversation. So Matt is going to be presenting today. Again, we are CapEx Sales. This is IndustryCast. It's where we go live at 11:30 every Wednesday with one mission, and that mission is to add value to our customers and to try to deliver some nuggets of information that'll help each of our customers be better at what they do, better at their craft, achieve a level of mastery. That's what we're all about here, is working to help our customers succeed. So that's what we want for you. We are grateful for all of our customers and very appreciative that you allow us an opportunity to serve you on a day-to-day basis. Man, look at that. Russ Sorrells has logged in 3 times. That is 3 times more than anybody probably really wants to experience. So with that, Matt, if you could, you start presenting, and then I think the second slide just talks about some of the companies we work with and kind of what we do. So fire away.
So is that working? You can see my screen?
Yes, sir. Got it. Loud.
First slide. Perfect.
Wide open.
Good morning, everyone. Just touching on CapEx really quick. We'll have maybe a 30-second sales pitch at the beginning of this call, maybe a 30-second sales pitch at the end, and we'll keep the meat in the middle as interesting as possible. So at CapEx Sales, we represent a handful of companies. ATC Automation, a very large and capable company based in Cookeville, Tennessee. A lot of repeat business, do work in many different industries, medical, automotive, etc. Cincinnati Test Systems, which we'll talk about a little later, the capabilities of Cincinnati Test Systems, but a very large global leak testing company. Duquesne Plastic Joining, hot plate welding, ultrasonic welding. Cymetric really does a good job of what do we do with all this data we have in manufacturing now. We have sensors on machines. We have connectivity to machines, but what do we do with that data? And Cymetric is really kind of a leader in that realm. So think Industry 4.0 there. And Keller Technologies doing industrial air filtration. Okay. So, why talking about this? Just a little background about me. I've been in and around the HVAC-R, so heating, ventilation, air conditioning, refrigeration industry for many years. I started back in 2005 working for a major HVAC manufacturer, probably one of the top couple names you think of when you think of air conditioning. I'll just leave it at that. For that company, I also led the manufacturing readiness efforts for flammable refrigerants for around a dozen plants. So I have a lot of experience learning firsthand what it takes to prepare a factory for flammable refrigerants and all of the governmental code standards, all the headaches that are associated with it. I've got a lot of experience in leak detection, been in a lot of work groups and discussions in the industry and with governments regarding flammable refrigerants, new refrigerants. And I've worked with pretty much all of the major manufacturers in North America in the HVAC-R market. So I kind of have a bold statement here, but I strongly believe there's more change now than ever in the HVAC-R industry. The major drivers of all the change we're seeing are obviously one of the things is ups and downs due to COVID. So there are actually ups to the industry due to COVID. There's a lot more focus on indoor air quality. So that's creating opportunities for manufacturers that were not there before. The home appliances market is going like gangbusters. I believe that's driven by the fact that everyone's stuck at home. So they're looking around at their old refrigerator, old dishwasher, and thinking, hey, why don't I replace that? There's bright spots in residential HVAC, I believe, for the same reasons. And obviously, there are bright spots in the medical and scientific refrigeration market. There are some downs. There's certainly some supply chain difficulties. Some of the markets are down, obvious things that everyone is dealing with these days. There are also a lot of changing applications just due to multiple factors. There is a lot more opportunity in the market for data center cooling. Obviously, as everything becomes more connected, everyone's got phones, there's just a massive amount of data that's out there. So there are a lot of data centers being built. And as you can imagine, the equipment in a data center produces a lot of heat, and that needs to be dealt with. With the legalization of a certain leafy green, there is a emerging market for climate controlling indoor growing facilities, indoor air quality again, and vaccine transport and storage. So you've probably read in the news that most of the COVID vaccine variants require very low temperatures to stay viable. So that is a huge challenge when you think of how do we keep something very, very cold and be able to transport it all over the world. So there's a lot of market opportunities there. There's energy efficiency standards keep getting tighter and tighter. That's nothing new, but it's still going on. The big thing that's really hitting the HVACR industry, and really anything that contains refrigerant, is considerations for climate change. So this is driving changing refrigerants, and that's mostly what I'm going to talk about today. So when we talk about refrigerants, you'll hear a term. Some people will just say GWP. Some people will say global warming potential. And global warming potential is the heat absorbed by a gas in the atmosphere when compared to that effect of carbon dioxide. So carbon dioxide's the benchmark. We call that GWP of 1. And then if something's 10 times worse than carbon dioxide with respect to absorbing heat in the atmosphere, it's a GWP of 10. So you can see traditionally, back in the old days, we were using refrigerants that were bad for climate and bad for the ozone. ODP is ozone depleting substances. Over the last 10 or 20 years, we went away from things that were ozone depleting. We moved from R22 to R410A in the air conditioning industry. And that's great because we get rid of ozone depletion concerns. However, we still have the global warming potential. So this next step that the industry is going is addressing that.
Hey, Matt, I just want to confirm that I'm understanding on that
Sure.
that slide. Does that mean that when we were using R12, it is 10,600 times more likely or holds that much more heat in than carbon dioxide? Is that what that means?
Yep. So if you released 1 pound of R12 into the atmosphere, say it leaked out of an air conditioner or refrigerator, that's equal to over 5 tons worth of CO2 equivalent.
Holy mackerel. So, I mean, over the course of years, we've obviously released a lot of that into the atmosphere. Mm-hmm. Does it naturally, I know you're not a scientist, but do you know if it just naturally dissipates over the course of time? Or
it takes a very long time to. That depletion is very, very long. If you look here, the global warming potential, there's different ways that you can calculate it. And these numbers shown here are the 100-year GWP. So
right.
yeah, it's considered a long-term effect.
Right.
That's a good question.
The propane there is what is it? Oh, it's methane gas. When cows fart, they let methane. So where's that on the list here? I don't see it.
Methane?
Yeah.
I'm not sure what the GWP is. It's probably in the tens.
Yeah, I'm just kidding. I know there's those a movement against the big farms that have all the cows farting. So
so yeah, this drive towards more environmentally friendly refrigerants, that sounds great. You know, what's the big deal? Well, there's this unfortunate property of many refrigerants where as they get more flammable, they get more, they have a lower GWP. Or said another way, the lower the global warming potential, often the higher the flammability of the refrigerant. So this, for manufacturers and for people in the field dealing with HVACR systems, this becomes problematic, obviously. We have decades and decades of experience with refrigerants that aren't flammable and that we don't have to take that into account as far as handling, charging in the factory, recovery, reclaim, all of that. So you'll hear some terms when it comes to flammable refrigerants. If you're in the refrigeration industry, you've probably heard A3. If you're in the air conditioning industry, you've maybe heard that A2Ls are coming. So this is really just an ASHRAE classification of refrigerants based on flammability and toxicity. So the letter refers to the toxicity. So A means it's low toxicity, B means it's higher toxicity. And then as you increase the number, you become more flammable. So when we talk about methane, propane, these are A3 things. When we talk about R32, R454B, these are, or R1234YF in the automotive industry, these are A2L refrigerants. The A2Ls are very different from A3s. A3 propane, very low ignition energy, very high energy ignition event. A2Ls are more of a flame propagation. It takes a lot more energy to ignite an A2L. The flame propagates much slower, and you need to have very specific concentration and conditions for that refrigerant to ignite. It's actually pretty hard to ignite an A2L refrigerant.
So A3 is gasoline and A2L is diesel fuel.
Yeah, that's a fair analogy, I would say.
Now I have a question and I want to, this interests me in that we have the heat exchangers, right? So that here in the South, we've got this forced air. How does that impact this? Because you're creating so much heat for forced air systems, it seems like that would be a real problem for a flammable situation or flammable refrigerant.
So for units that will have what's called a direct system, where the heat exchanger is in the airstream that is going into an occupied space. So not a chiller, right? Because the refrigerant's in the chiller and then water is going to the heat exchangers. But in a direct system, there are new standards and requirements for the design of the air conditioning unit that the system has onboard sensors, and that if there's any approach towards the lower flammability limit of the refrigerant in the unit, it will take action, such as shutting off the compressor, keeping the fan going to dilute the refrigerant that leaked, that sort of thing.
Oh, wow. So it's going to get to the point where they might need a fire suppression system on every one of them, right? But hopefully not.
Yeah. So the plan is to just have sensors and controls to mitigate that risk on the unit. So it's something manufacturers are working on now and trying to figure out how to deal with in the air conditioning space.
Cool.
For small refrigerators, the charge of A3 refrigerants is so small that that's not as much of a concern. So I'm not going to spend any time on this, but just for everyone to be able to refer back to this slide as a glossary, if you hear HFC phase down or HFO or blends or natural refrigerants, what the heck does that mean? You can refer back to this slide. So where's the industry stand now? So most small self-contained refrigeration has moved into the A3 direction. For domestic refrigeration, like the refrigerator you have in your kitchen, or maybe your beer fridge in your garage, if you're lucky enough to have one of those, most of those have gone to R600A, which is isobutane, but again, very small charges measured in tens of grams. Commercial and vending is very similar. Most of those applications have gone R290, which is propane. In the medical refrigeration, there's multiple refrigerants that have been deployed, most of them A3s, and they have multiple refrigerants because there's multiple different applications in medical, ultra low temperature, all these different temperature ranges and applications that demand the need for multiple refrigerants. Automotive air conditioning, not technically part of the HVACR industry, but it's interesting to note that they have mostly switched to R1234YF, which is an A2L. So if you have a newer vehicle, you're probably driving around with A2L refrigerant. Another note in the automotive side, electrical vehicles do not have a coolant circuit going to an engine. Obviously, there's not an internal combustion engine. So that cannot be tapped for heat. So this application may drive other refrigerants, maybe even CO2, that can be run as a heat pump. So that your climate control system can either heat or cool. And some large refrigeration applications like supermarkets and large refrigerated warehouses have moved to CO2 or ammonia. So where are we headed? Everything I just talked about is leaving out, air conditioning of buildings. And that's really what's going to be changing here in the next 5 years. The air conditioning industry is mostly going to switch to A2Ls by 2025, 2026. There is an A1 refrigerant out there that's being marketed as meeting the GWP goal of being below 750. But it has major drawbacks, cost, material compatibility issues. So I'm not sure how widely that will be adopted or not, but it's something to be mindful of. Chillers, which are a lot of, I would say maybe half of the chillers in America will be, new chillers made in America will be converted to new refrigerants by 2024, and that's going to be a mix of A2Ls and A1s, depending on application, pressure. Is it a water-cooled chiller? Is it an air-cooled chiller? Is it a scroll compressor? Is it a screw compressor? So there's going to be some mix of flammable, quote-unquote, mildly flammable, and quote-unquote, non-flammable refrigerants. Mobile refrigeration, I think we're still at least 5 years, 10 years away before they really start looking at A2Ls or A3s in that space. But there's an interim step of going to lower GWP non-flammable refrigerants. And there's some more niche markets, ice machines, dehydration, pool heaters, water heaters. With all the regulation changes that are going on, I'm not really sure where those things will fall out. So I would say stay tuned. So why, when, where is all this happening? Why are we doing it? Well, so there are now federal regulations. There was a bipartisan legislation drawn up last year called the AIM Act to essentially make this happen. It didn't get voted on last year, but it did get crammed into the COVID relief bill. So it is now law. And this law enables and requires the EPA to phase out HFC refrigerants. lower the GWP of refrigerants they're putting into products. And the industry is anticipating that these rules will hit air conditioning probably 2025, 2026 timeframe. The details of that still need to be worked out. It's still new legislation, and the EPA has to make their rules according to that legislation. Our new administration in the United States is very much climate focused compared to our previous administration. We're signing and re-signing climate agreements internationally. You've probably heard of the Paris Agreement, the Montreal Protocol, the Kigali Amendment. Those are these things where countries are agreeing that they'll phase out these higher GWP refrigerants, as well as taking other climate action. The ICC is working on revisions to the International Fire Code and International Building Code to give A2Ls their own hazard classification and increase the allowable quantities you can have in a building. This enables manufacturers to actually, charge units with this refrigerant over certain amounts. The current MAQ is 150 pounds, which does not work for a lot of commercial refrigeration and air conditioning applications. There's also been state-by-state action over the last 4 years because of a lack of federal action. So some of the a lot of the blue states have put rules into place that are going to regulate the GWP of refrigerants that you can put into new units. California, New York, and Washington are working on AC. Those states and 13 others are working on chiller regulations that are enacted January 1st, 2024. And Canada has a law in the books that is requiring lower GWP refrigerants starting January 1st, 2025. How are we doing on time, Russ?
We are doing great. We got 8 minutes. So
okay, excellent.
Doing great.
So what does this mean for manufacturing? If you're a manufacturing engineer in the HVACR industry, what does this mean for you? Well, the first thing is there's all these new codes and standards you have to follow that we weren't concerned about as an industry with A1 refrigerants. How you handle flammable gas, how you store a flammable gas, how you monitor to make sure that you're not creating an explosive environment. It requires you to use hazardous rated equipment where there is a potential for leakage of this refrigerant. So your refrigerant charging equipment, your refrigerant reclaimer equipment in your manufacturing building probably has to be class 1 div 2 now. Certain equipment used with your bulk storage, if you do bulk storage, may have to be class 1 div 1 rated. When you install your new A2L or A3 refrigerant storage and charging system, you'll need a professional engineer. You'll need piping and instrument diagrams. You'll need this to be signed off. You'll have to take it to the local authority having jurisdiction, which may be a fire marshal or local code official. A lot of things in this project that haven't existed in similar projects in the industry earlier.
That's an interesting. I just want to touch on that.
Yeah.
So with the newness of all of this, the likelihood of a local fire marshal knowing the specifics as it relates to how to determine if this is adequate, that could be a struggle.
Yes,
that's a struggle.
It can be.
And when you've got 100 years of something that's experience, right? Let alone something that's brand new.
Yes, and there's going to be some knowledge gap with the local officials that they may not have any idea what you're talking about. You may have to actually educate them.
Yeah, so that was my next question is how would you recommend that these companies tackle that? So when there is something that is that they're going to have to get through the local authorities that may not be as up to speed, what recommendations would you have for educating them?
The number one thing is start the process now, start the dialogue now, start your internal plans now. You know, people may be seeing 2025 dates and think, oh, that's no big deal. But the approval process with the local authority, that could be a year delay. It may take, you know, 6 months or a year to get the equipment you need. Now, you know, we're at 2 years now. That's if everything goes to plan. So the number one thing I would say is start planning and talking about this early and involve people who are experts. I don't think a manufacturer is going to be able to figure this out on their own without help.
Great advice.
So there's another regulation. If you're a larger manufacturer and you've got 10,000 pounds or more of an A2L refrigerant, say in a bulk storage tank or in a process, as OSHA calls it, you have to go through and initiate this thing called PSM, Process Safety Management, which is, it doesn't sound like a big deal the way I'm describing it, but it is a huge amount of work. It regulates how you manage safety in your facility, how you manage training, how you manage preventative maintenance, how you manage documentation, on and on and on. It's 14 element, essentially safety management program that you have to comply with.
Wow. What if you broke it up and you had 5,000 pounds in one and then 5,000 pounds in another? Would that still
There's some games you can play. I don't recommend playing those games because I've been trained in OSHA PSM, and comparing that training and how that safety management system works compared to what I've seen in the industry, I would be concerned for any manufacturer that is doing flammable refrigerants, charging flammable refrigerants in their factory, and they're not following PSM.
I got you.
So my personal opinion is PSM is the right thing to do from a risk perspective.
I see. Yeah, the consequences far outweigh the effort to do it. Okay, I got you.
And in the industry, there's a long and unfortunate track record of major releases in manufacturing facilities of refrigerant. So if there is not a fundamental, you know, safety management change, that frightens me a little bit.
Gotcha.
So where we're handling these refrigerants, there's going to be new safety systems. There's going to be at least emergency ventilation. There's going to be refrigerant concentration monitoring. You may need to build walls around your charging station. There's line layout issues because you obviously don't want to be brazing with an open flame near where there might be a release of flammable refrigerant. Likewise, you probably don't want to be doing high voltage testing adjacent to where you may be releasing flammable refrigerant. So you may have to do some work balancing, especially on the commercial side, where it takes an hour or two to charge a unit with refrigerant. A manufacturer may have other work that's going on that unit in that charging work cell that they might have to balance to other parts of the line because that work is not safe with a potentially flammable environment. It's not legal to ship a lot of units over a certain charge with flammable refrigerants, so that's being worked on by the industry. Charging stations, like I said, may look very different than they do today, and proper leak detection is necessary. It's not just a quality thing. It's not just a warranty cost business decision. Refrigerant leaks, if it is a flammable refrigerant, is now a safety issue. You could be burning down buildings, killing people. Leaks are a big deal with flammable refrigerants, so you need to make sure you have proper leak detection.
And now leak testing. So used to it was considered a non-value added process, but now it can actually save lives.
Yep. So I promised there would be a 30-second, or warned you there would be a 30-second sales pitch at the end here. So Cincinnati Test Systems has solutions to help you down this road. We can help you with sniffing. We can on problematic joints, such as an aluminum to copper transition braze joint. That's a very problematic joint right now in the HVACR industry. A lot of leaks, warranty concerns there. We have a patented technology where we can actually encapsulate that entire joint with a clamshell that purges with nitrogen to get you a clean signal. And we can do a very nice leak test on that joint. With flammable refrigerants, you might want to take your compressors or your heat exchangers to the next testing level. If you're doing sniffing now, you may want to go to a hard vacuum helium leak test system. And of course, CTS also can do calibrated leaks of all flavors and sizes.
Fantastic.
And I'll say this, CTS is also working on development of other technologies that might be interesting to a company that is going down the road of flammable refrigerants. I can't really talk about those details right now, but if you are one of those manufacturers, we'd love to incorporate your needs into our development.
Wonderful. Well said. So,
Russ, I'll let you wrap it up if you'd like.
Oh man, I tell you, Matthew, that was fantastic. Very informative, very specific, and definitely added a lot of value to the customers that we have that are in that industry. So, thank you for being willing to share your knowledge for sure. So, this is the team at CapEx. We got Matt Matheny. He's there in South Carolina. He's also focused on Western North Carolina and those select upstate accounts. Also, and then we've got, of course, Chris Mullins, decades with, over a decade with CapEx. He's located in Eastern North Carolina as well as Virginia. And then I am supporting Matthew in Western North Carolina in the upstate account. So we cannot thank our customers enough. We exist because of you. If there's more of these industry casts that make sense, that would add more value to you, please let us know. Next week, we've got Jonathan Ray, who's going to be on from Weber USA. Weber is a leader in part feeding torque systems. So excited to have him on next week to talk about what that company is up to as it relates to new products and new things that can help customers improve and make their processes more repeatable. So that's what we do here on IndustryCast. We welcome your feedback again and ideas. Thanks again, Matt.
Yeah, thank you, everyone.
All right. Have an awesome day.